Good evening to everyone. In this video I will present all the new features that are included on the latest update of Tremuri project, which is called Tremuri Project Open. Tremuri Project Open is the new feature that allows us to essentially calculate structures that do not present box-like behavior. If we remember, box-like behavior is a fundamental requirement for to perform a pushover analysis and to analyze a structure. So in some cases we are going to be presented with structures or buildings that do not have this box-like behavior, and under this requirement Tremuri Project Open is born. With all the new features that are included inside Tremuri Project Open, now we are going to be able to calculate the seismic vulnerability of structures that do not present box-like behavior. On this video we will see a real-life example on how we can use Tremuri Project Open to calculate the seismic vulnerability of a building. In the case that we see on the screen, this is an very old church that doesn't have any horizontal structure, so as we can see here. So this is a classical example of a building that does not present box-like behavior. So we are in front of the difficulty of how to model some of the elements of this structure. To try to approach this problem, we are going to use the new feature, one of the new features that is included inside Tremuri Project Open, which is the vertical plane input. The vertical input mode is now a new feature that goes along with the input by level that we could usually find on Tremuri. So with this new type of input, we can now introduce geometry elements to the structure that have a more complex geometry that would otherwise be very difficult to introduce with the classic input by level. So as we see here, we are going to model the facade of this church. In order to do that, we are going to use a DXF file as a support. So we just click on the icon that allows us to manage the DXF layers, and we are going to choose a DXF file that already has the borders of the facade that we want to input on the structure. So we first take a look at the scale, we introduce the scale and the point of its insertion. And as we see here, the facade is quickly introduced into the model. So this is going to be just a geometric support that is going to help us in the input of the structure, and we are just going to go ahead and assign to this wall alignment, we're going to assign its mechanical attributes. So we just click on the icon that it's similar to the one that already existed in Tremuri, and we are going to choose the thickness of the facade that we want to introduce. We are going to also choose a material from the library, and what is new on this input mode is the type of input that is going to help us on the introduction of new elements. So apart from the original rectangles that we could use, now what is new is that we can use a polyline method to trace the borders of more complex elements as the one that we are presented with now. Once we've selected the input mode that we are going to use in the input of our facade, we just have to begin by tracing the polyline that defines the edges of the facade that we want to introduce. As we see here, we have the option to introduce not only straight lines but also arc segments that is going to be very useful in the insertion of very complex geometries, which is one of the potentialities that this software now has. So as we see here, we can change between the modes of introducing a straight line or just introducing the arc segment. And we just close the polyline and right click, and the border of our facade is already introduced. Now we will continue by introducing the openings of this facade. Another new feature is that apart from the classic rectangular openings that we could usually introduce in Tremuri, now we have more options. We have the options to introduce rectangles, circles, ellipses, and also polylines. In the case of, for example, these entrances that have an arc shape, we can just use the polyline method to introduce them. As we see here, this can be done very quickly and effectively with just using the polyline command. I'm going to keep on introducing the rest of the openings for this structure. So as we see here, the snap function of the DXF file that we already introduced is very useful in this task because we can do it very quickly and in a very precise way, as we see here. And with that, the three openings are inserted, and for the window we are just going to insert a circle by selecting the 2 points of that circle. And with all that, the facade of our structure is inserted. If we take a look on the 3D view, we are going to be able to visualize it on the 3D model. As we see here, the facade has been successfully inserted into the model. If we want to go back to the plane input mode, we can see that all the alignments that were modified on the elevation view input are going to be seen as a trace line on the plane. We are just going to go ahead and continue with the modeling of our structure by introducing a wall that is located in the middle of the church. To do that, we are going to proceed in a similar way by inserting a DXF file that we are going to use as a support for modeling. And on this case, I'm just going to introduce wall segments with the polyline method, but in this case I'm just going to trace the whole border of the structure. So if we see here with the snap functionality, this becomes a very simple and fast task to do on the insertion of all these walls in this case. So we are just going to select over here and just keep on tracing the border of this wall over here. Once we're finished, we just have to finish and right click, and as we see here, the wall has already been inserted. And if we go to the 3D view just to see our results and to visualize the wall that we've just inserted, as we see here, it's present in the middle of the structure. Given the fact that this structure does not present box-like behavior because it doesn't have horizontal structures such as floors, we're not able to perform a global analysis such as pushover analysis. So in this case, we're going to go ahead and do a kinematic analysis to perform local verifications on the elements that we've just inserted. In this case, we're going to go to the kinematic analysis environment that was already present in other versions of Tremuri, and we are going to perform a kinematic analysis, on this case of a turnover analysis of the whole facade of the church. So in this case, we're going to insert a kinematic that it's going to be called kinematic number 1, and we are going to choose, this is a new feature on Tremuri Project Open, now we can choose between out of plane or in plane kinematics. So in this case we are going to go for an out of plane kinematic because it's a turnover of the whole facade. We're just going to click OK to create the kinematic analysis, and in this case we are just going to select the whole facade because that is what we want to analyze. And in this case, the insertion of the whole kinematic block already has into account the masses that are not present due to the openings that we see on the facade. So we're going to go ahead and insert the hinges. In this case, we are going to locate the hinge at the base, given the fact that we want to see the turnover of the facade out of its plane. And we are just going to go ahead and calculate the kinematic analysis of this configuration that we see on screen. Once the calculation is done, we are presented with the results window. What the results window is showing in this case is that the verification is not being satisfied, given the fact that the capacity acceleration it's lower than the acceleration of demand. And in this case we can also see the activation multiplier of this kinematism, which is visible on screen. If we click OK, we can also take a look at the deformed shape of the structure as an animation on the left side of the screen. Also, if we go to the 3D view of the model, we can take a different look at the deformed shape of the structure. So as we see here, this is the deformed state of the kinematism, and this is the undeformed state. One of the new features that Tremuri Project Open offers is the calculation of in-plane kinematics. So for this example, we are going to proceed with an in-plane kinematic calculation for the alignment that is located in the middle of the building. In this case, to create another kinematic, we are just going to go to the menu and create a new one. By going to the menu, we are going to be able to create a new kinematism. We just have to insert a new one and fill in the description with the name of the kinematism, and for this case we are going to choose the in-plane type of kinematism, which is the new feature inside Tremuri Project Open. Once we've created the kinematism, we just have to go ahead and create the blocks of the kinematic chain. In this case, we are going to use the shortcut create block by panel, and then we are going to divide it. With the divide command, we are going to choose different hypotheses of fault lines, fracture lines that are going to transform our single wall into a kinematic chain of rigid blocks. So what I'm doing here is dividing the whole kinematic block into smaller segments that then we're going to put together with hinges. Once we're finished, we just have to go ahead and insert the hinges. Given the fact that this is an in-plane kinematic, we have two types of hinges, internal and external. So I just go ahead and create first the external and then the external hinges that are going to define the way that this kinematism moves and this has displacement. So after that, we are going to be presented with the type of analysis that we want to create. In this case, we're going to go for a linear analysis. So once the verification is done, we can see that it's not satisfied given the fact that the capacity acceleration is lower than the acceleration of demand. We can also be able to visualize the form shape or how the mechanism evolves and progresses along as the seismic forces increase. So we can see this on the screen. This is a very similar functionality that was already available for out-of-plane kinematics. And a new feature with Open is that we can perform a non-linear analysis. What a non-linear analysis is going to do is going to take into account the displacement of a control node, and is going to compare the capacity displacement with the displacement of demand. In this case, we can see that the verification is satisfied. And another feature that is going to be available is the capacity curve that compares accelerations with displacements. So we can see the evolution of the kinematism beyond its initial configuration. If we click on the 3D view of our project, we are going to be able to see both the deformed and undeformed states of our kinematism within our 3D model. Now let's go with another example of a structure that does not present box-like behavior, so we cannot perform a global analysis. As we see here, this is a structure that doesn't have horizontal structures that are going to be able to guarantee a global behavior. So in this case, we are going to go ahead and use a DX file as a support to insert all of the 4 facades of the building. Similarly, of the case that we did previously, we are going to be able to insert with a polyline the wall shape that it's going to be forming this facade. As we can see, this is a very, very simple and fast task that we can perform with the polyline input mode. That allows us to not only insert straight lines but also curved lines. So in this case, we can be able to input very, very complex geometries. Once we're done, we just right click and our wall has already been inserted. And if we go to the 3D view, we are going to be able to see it located within the model. So once we are done importing and inputting all of the 4 facades, the model is going to look like this. This is the finished view of the model, and we're going to be able to perform our local verifications to be able to verify the seismic behavior of this structure. So in order to do that, we are going to go to the kinematic analysis environment, and we are going to create a new kinematism. We just, similarly with the case that we saw earlier, we are going to fill in the description, choose an in-plane type of kinematism, and just click OK to create it. Then we select the alignment where we want to create it, create block by panel, and very similarly to the case that we saw earlier, we are just going to go ahead and divide it into smaller segments to start making the hypothesis of our kinematic chain. In this case, I'm going to divide the wall into several segments. as we see here with the command divide, this can be done very quickly to just in a matter of seconds create the kinematic chain. Then we are going to go ahead and insert the hinges, internal and external hinges, to make this chain a liable one. So then we exit, and for this case we are going to perform the calculation, and we are going to perform a non-linear calculation, just leaving the default settings of control node and number of substeps. As we see here, we have a satisfied verification, and if we take a look at the capacity curve, we see all the relevant parameters that are present. A new feature that we have inside Thermody Project Open is the tie rod wizard that allows us to input tie rods into our structure with a more complex parameters within. So in this case, I'm going to select to insert a tie rod in this part of the structure, and then we're going to click OK to see the impact of the insertion of this tie rod. As we see here at the beginning of the capacity curve, we can see the impact of this tie rod by increasing the capacity at the initial configuration of the kinematism. If we click on this icon over here, we're going to be able to see the form shape. We're going to see the progression of the kinematic chain as the lateral forces increase. On this last example, we are going to be using a different type of support to insert a vertical structure. In this case, we are going to use an image as a support to insert a facade. So this is a typical example of when we are using a polyline to trace the borders of a facade using a picture that is going to help us with the insertion of a structure. In this case, we don't want to model the whole structure. We are just looking to model just the facade, and we are going to add in all the loads necessary to take into account the rest of the model. So in this case, it's not going to be necessary to model the whole structure, but just to model one of the walls, the wall that we want to analyze. So as we see here on the 3D view, has been successfully inserted, and now we are going to go to the loads section in the vertical input mode, and we are going to insert the loads that represent all the actions, all the loads acting upon the structure. So we first are going to insert some concentrated loads that are going to represent the weight of the structures above the roof. And then we are going to go ahead and insert some linear loads that are going to represent the weight of the roof acting on this facade. So just go ahead and insert the parameters and change to a linear type of load. And just by clicking on the facade, we just can quickly insert all the loads that are representing of the roof weight. Also, we can insert some different loads that are going to represent specific actions on our structure, such as, for example, this one over here. And also we can introduce some loads that represent the actions on the sides of the building. By doing this, it is not going to be necessary to modulate the whole building, but just the wall that is under analysis. If we go to the kinematic analysis environment, we're going to be able to perform local verifications of the structure that we just inserted. inserting the description, and in this case we are going to assess the turnover of the facade and part of the facade of the building. So as we see here, we just insert the block of the whole facade. We just leave the seismic parameters as they are, as a default, and we just perform the kinematic analysis. As we see here, is not a satisfied verification according to the Eurocode. And if we just click on this icon over here, we're going to be able to see the deformed shape of this kinematism. We can assess another case that is going to be the turnover of just the upper part of this facade. And we can do this very quickly by creating a new kinematism and creating a new block that only takes into account the upper part of the building. All the loads, of course, are going to be imported from the structure environment. And we just insert the hinge on the upper part, and when we go to choose the parameters, we're going to choose that we have an elevation constraint given the height of this portion of the building, and we can see that the program calculates the verifications for both cases. Also, we can just take a look at the 3D view to see how the deformed shape is going to affect the whole building, as we see over here.